Today I wanted to talk about reality-driven testing using test containers. It's kind of like a fancy title for basically how to use test containers and why you should use them. This is meant to be kind of like an online workshop, but I guess it's more structured like a half a talk, half a demo. So I'm not really sure what to call it, but I hope it still will be useful. So before we go too much further, let me introduce myself a little bit more. I'm, again, like I said, Oleksii. I currently work at Bitwarden and previously worked at Sentry and some other companies. And mainly I focus on developer tooling and experience. So everything that as a developer you use matters to me, and everything I work on is somehow targeted at making developers' lives better. And this is really just feels really rewarding to me because as a developer myself, I know what other developers typically want. So, it feels good when you can see how your work can impact them. I'm also an open source maintainer, and you may have been using some of my projects, at least the NuGet packages such as CLI Wrap, maybe YouTube Explorer, CLIFX. I maintain about, I think, 10 more repositories in various toolkits, I guess, or ecosystems. And this has been pretty much my main way to spend my free time, for better or worse. I also write and talk about different technical topics. And I just love kind of discovering new things and finding better, at least to me, better ways to do certain things in terms of development. And it is really nice when you can share with other people. So before we go,
By the way,
yeah.
By the way, we use your CLI Wrap project.
Yeah.
That's why we also wanted to sponsor your open source activities. What we have been doing, I believe, for about 2 years.
Mm-hmm.
And by the way, we also use Bitwarden as
Yeah.
our password manager. So that's quite cool to hear.
Yeah, so I guess we have a lot of things in common, we can say. Yeah, but let's take a step back a little bit before we dive specifically into test containers. Test containers isn't necessarily a new technology or like a completely different way of doing things. It has actually been around for quite a while, but I feel like it's not nearly as popular in terms of like .NET ecosystem as it is in some other ecosystems such as like Java specifically or Node.js. But before we go into that, let's take a look at why do we need testing in the first place. So in order to talk about what kind of problems test containers may solve, let's see why we would have those problems in the first place. So the premise of testing in software development, regardless of whether it's automated or manual, that part doesn't matter, is that we want to gain confidence that the software or the code that we wrote works correctly. And typically, we do that by writing automated tests that kind of repeat the same behaviors, the same interactions that a user would experience with your codes or with your API or like with your UI, doesn't matter what you're working on. And if that test completes successfully, then we can probably say that what we wrote, the code that we wrote, works correctly, at least according to the specifications that we outlined. And the confidence that we gain from testing is not a constant thing, right? It changes based on authenticity of our test processes and the test environments that they operate in. So a more authentic test process would provide more confidence, and a more contrived test process would provide less confidence. What that means is, for example, if we have a product, let's say a storefront, where you like choose some items or products that you want to buy, you add them to your cart, then you put in your address, maybe pay for it, or probably pay for it, and then check it out and get the products in mail or something like that. So that's a typical user story that's built out of multiple steps, and you want to make sure that the user can complete all of them and get what they have paid for, and you would get the money that they paid. And in order to properly test that, it would require you to repeat the exact same steps that the user would take. And a testing process that would do that would be very authentic because it does the exact same thing that the user would do and repeats the exact same scenarios. A more contrived test process would not be exactly like what the user would experience or behave. It would probably take some shortcuts. It might use a different environment, or it might not like go through all of the steps. It might skip some of them. And as a result, we are still testing some parts of the user interaction and hopefully the useful parts, but we're not testing all of it. And as a result, when such tests complete successfully, we can less confidently say that the product that we're working on actually works correctly. And conversely, if the tests fail, we're not really sure if the problem is within the code that we wrote in our product or the tests themselves. And why would we even like bother with such contrived test processes in the first place? And the reason to that is that some components may just be hard to test in our product. And that can be for a number of reasons. First of all, they cannot be easily accessible. So imagine, again, the storefront uses a third-party cloud service. Maybe it's not very maybe it's not containerized. Maybe it does not have an emulator that you can run locally. You don't want to create new resources to properly isolate your work, especially if you're doing it locally. And so you might choose to you might decide that that component is just too difficult to test properly because it's just not accessible. In a similar vein, certain components can be non-deterministic, which means that they depend on outside effects. It could be a third-party service, an API maybe within your company, but not the one that your team works on. It could be just something that does not make sense if you isolated it from third-party or outside effects, such as like, I don't know, a weather application. And again, such components which are not deterministic may be difficult to test because their state changes all the time. And finally, one of the main reasons is because certain components are slow because they are reliant on heavy I/O or just heavy computations. Again, a good example is just downloading a really long file or transferring it from one point to another may just take a long time because of network latency and things like that. Or computing things like a factorial of 1,000. I don't know. It's going to take time regardless of where you run it, and it may be very important, but it's still going to be slow. And this is kind of what we're trying to avoid usually. And in cases where this happens, or in scenarios where this happens, we're used to replacing such components with test doubles. So it's either fakes or mocks or any other stubs. The point of which is that we basically decide not to test the real components because of all of those three reasons that we just mentioned, and instead replace them with something that acts similarly or reacts similarly to at least the predetermined responses, but is not the real thing. It's much simpler, it's much faster, it does not depend on anything, and such test doubles allow us to test different components in isolation from each other. So we can, again, going back to the storefront example, we can test several steps independently and maybe make sure that, for example, when we put in our address, that it's sent correctly to the API or to the server, or maybe stored in the database, but we're not going to be testing how it's going to be pushed down the pipeline, like whether the product is going to be delivered. And we're also not really, like, we probably wouldn't care about what happens before that. And this does allow us to test things more easily and gain some confidence, but ultimately it reduces authenticity because it results in fragmentation of tests, of scenarios they're recovering, and sometimes it's just really hard to derive confidence from tests that either complete successfully or fail and understand what that means. So in a general kind of guideline, we should probably aim to prioritize confidence and only reach for test doubles and other things that kind of work as a workaround when we need them, and so avoid them if we don't need them. In practice, it doesn't always look like that, and a lot of developer testing suites end up looking something like this, where we have a test, and as you can see, it's an XUnit test, and it kind of relies on some mocks. As you can see, there's a mock service provider, mock passwordless client, And maybe it started off simple, maybe like it went through several iterations. It was definitely written with good intentions, but at this point, whenever you look at this, or at least to me, my personal opinion is the only question you can ask is, what the fuck is going on here? Because there's so many things being set up, there's so many different conditions, and if you look at the title of the test method, which says add credentials async, which is probably the name of the method, app requires email, which is I guess some feature or a condition that is being tested, and then creates options with email alias, meaning the result that the test is meant to verify. But if you look at this test, it's not entirely obvious what the hell is it actually doing, and partially it's because it's not actually very similar to how the end user is going to be using your API or your code. It doesn't look like anything like the code that the end user would write, and partially it's also because with mocks you're kind of having to rely on implementation details. You have to know how internal aspects of like a certain method reacts to certain parameters. So for example, here we have to outline the possible parameters to this method, which values it can take. And that's a lot of assumptions being made on the implementation details. And that's not really the assumptions we want to make because it makes the test fragile. If we change something about the actual method that we're testing, the implementation of it, or even something simple as just like rearrange the parameters in the method, we also have to change the test. Otherwise, it would fail. And this is very tight coupling as far as testing is concerned, and not something we really want to be looking for. So let's go back to reasons why we want to use real dependencies. That was kind of like an example of what testing using mocks could look like. But more generally, the reason we don't like test doubles is because they erode confidence. Because like it's harder to tell which how much of the application surface is tested because it's very limited. You can't exactly easily just look at the test and know which part of the application it covers. It can also cover impossible states in certain cases. For example, and a pretty common occurrence is when a test and a method is written at a certain time, but then the method actually changes, or maybe the usage of the method actually changes from the outside, and then the test actually verifies, for example, a parameter that cannot be realistically passed. And that could either mean that you're wasting effort on tests that are not verifying something that can actually happen, or it can also damage your confidence in the tests that are actually useful, but are trying to verify a scenario by imposing a state that the user cannot impose. And that often also happens when you're doing something with internal state, so something that the user cannot observe. If you're changing that and everything, for example, works fine, but then something changes and it breaks, it's not really obvious what exactly caused that issue. On top of that, crucial infrastructure concerns are not tested. So things like database interactions in typical CRUD applications or in a web application could be things like request routing and handling. And those are very important concerns, and especially in terms of like database interactions, a lot of the business logic is developers often encode a lot of the business logic unknowingly in their database interactions. So things like constraints where certain entities cannot coexist at the same time, or like the order at which certain things are added to the database or read from the database, concurrency and things like that. Those can impact how well your application works. And it's not about whether the database works correctly or not, but it's more about how you're using the database. And with tests like these, because databases are inherently, they're very I/O focused, they're often slow, they are sometimes unreliable in terms of like external services if they're cloud native databases and things like that. So we typically don't really focus on those interactions in terms of testing. And then same thing goes for request routing and handling. That takes care of validation. It makes sure that certain requests are not possible at all. They cannot reach your API. And again, this has to be tested. It doesn't often get tested. If it does, it often gets tested in isolation instead, so it's not really perfect. And mocks specifically, while they're not the only type of test double you may have, they specifically make tests more complicated because they, as we already saw, they introduce a lot of cognitive overhead in terms of the testing setup. So in order to test a certain scenario, like if calling a method results in a certain outcome with certain conditions, you have to instrument all of the dependencies to work in a specific way that the method actually experiences or like has those conditions working the way there should be. And in order to do that, you have to know how those dependencies are used by the method. You have to make some assumptions about the implementation details, or you have to know how they work. And it also makes the test very difficult to understand. An ideal test is such that you don't have to know anything about how the actual system under test is implemented, but you can look at the test, and just by looking at it, assuming it completes successfully, you can immediately feel like it actually does work correctly. So if you have, like, for example, a basic example, a hashing algorithm, you don't have to understand how the hashing algorithm works. It's probably going to be very complicated, but you do understand certain properties of how the result should work, like, different inputs should provide result in different outputs, the length should be probably constant, things like that. You can test those things very trivially, and if you test all of the things that matter to you, you can still infer a lot of confidence about the product you're working on without having to understand how it works. And at some point, if your tests do get really complicated and they contain logic, which testing setup is kind of logic in itself, you may ask a rhetorical question of at which point do we need tests that test those tests, because they get very complicated. But ultimately, it's not like we can do better, right? We can't just use real dependencies, or can we? And this is where containers come in, and specifically Docker containers. And I'm sure that everybody watching this, I guess, presentation is aware of them, has been using them. It's not a new thing. It pretty much changed the software development world quite a bit, and basically it just allows us to take most of our infrastructural dependencies, or any dependencies really, and spin it up in our local environment or in the cloud or in our CI/CD pipeline without worrying about the host environment. We can also spin up multiple instances of these containers. They can all communicate with different applications. And this is great. And this sounds like something we should be using with tests. And a lot of people have been using these containers with tests. But test containers specifically, it's kind of like built on top of that. And it allows us to work with containers in our tests more fluidly, because it already takes care of a lot of the dirty work for us. And specifically, test containers is essentially just a container orchestrator that is code first. It's kind of like Docker Compose in the sense of being an orchestrator. What that means is that it's a tool or a framework that you where you kind of just tell it what kind of containers you need to be running for your application, or in this case, the tests, to be running correctly. And then you tell, for example, which ports to expose, which health checks to use, things like that, which images, and then it just makes sure they're all running, that they're all healthy. And once that's done, it takes care of eliminating those containers gracefully, making sure all of the resources they're using are freed up, and allow us basically to use these containers without thinking about all of the actual management aspects of it. Of course, we can also just have tests that, for example, use the Docker CLI or the Docker API, and we can run star containers and shut them down ourselves. And I've seen that a lot in certain projects as well, but test containers already takes care of that. It's kind of just so that you don't have to reinvent the wheel. It's also a framework that is available across multiple platforms, and it tries to maintain a single API. So it's kind of like there is an universal idea of how to use those containers as a framework, and there are different conventional APIs for different platforms. There's an SDK for .NET, there's one for Java, there's one for Go, Node.js, Python, etc. And all of those SDKs are, of course, more focused on the actual language patterns, the ecosystem they're in. But ultimately, if you learn to use task containers in one language or paradigm, it's easy to adopt it in another. So if you're in a company that uses multiple development platforms, that can be very useful because you can adopt it across all of your teams pretty much if you decide to, and it's not going to be that big of a deal learning it. Also, it works anywhere where Docker is supported, so you can use that, of course, locally if you have Docker installed. You can also use it on your CI and CD pipelines, and it doesn't really matter what you're using for that. You can be using GitHub Actions, you can use Azure, AppVeyor, whatever. And pretty much everything supports Docker nowadays, so you can just say it works anywhere. It is open source, the community maintained. It is there's a foundation, or I guess technically a company, I'm not really sure of the specifics, that owns TestContainers, but ultimately it's an open source project, and it has a very well-developed community. There's a lot of people working on it. There's a lot of people contributing documentation, blog posts, talks such as these ones, and it's just basically what every other open source project is, and that's great in my opinion. It also has a lot of built-in kits for popular services. So you might be using a MS SQL database in your application. You don't have to do a lot of wiring by hand. You can just use in .NET, for example, you can just use an existing NuGet package that is, again, official by TestContainers or by the community, and it will do a lot of the work for you. So it would provide convenience methods for generating connection strings. It will know exactly which image to pull. So it all comes down to just writing a few lines of code and you're just good to go. And the same can be said about many popular services. So most likely things that are using, especially if they're also open source, there's going to be a kit for it. So the effort to get it running is going to be really, really low. And then the final point, which I personally think is pretty important, but often overlooked, is that you get a single reusable infrastructure setup. And what that means is that once you put all of the effort in terms of writing the code for your test, making sure the lifecycle works as supposed to, integrating it with test containers, once that's done, for the most part, you don't have to touch it. Assuming it works correctly. So you only have to change your testing setup, or the how it spins up dependencies and things like that, only when your infrastructure changes. And for comparison, if you have tests that mostly rely on test doubles, if you, for example, need to build or write new tests for a new method or a new class or a new feature, it doesn't matter the level of granularity you're going for, you're going to be having to set up new test doubles. Bitbox is, doing all of that setup again with fakes. If you have any new dependencies, you have to program them. You have to make sure they're behaving in the way they're supposed to. So with each new test, there's that overhead of infrastructure setup. With test containers, assuming, of course, everything works well within the containerized environment, then it's just a one-time fee that you have to pay in the beginning, and that's it. And also another
big question here. In our tests, specifically in our UI tests, we use Azure it, which is an Azure Blob Storage Emulator, as well as SQL Server. Under certain tasks to test those when our applications in production run in Azure and use similar services. So I've seen that TestContainers has, and you also mentioned MS SQL. I've seen that TestContainers has support for these.
Yeah.
These are less of an issue, still something that we have to care about. Less of an issue in CI because there are already GitHub Actions reusable or community actions that install those. A bit of an issue locally because you have to install these tools. But what's a major issue, and the major issue, especially under GitHub Actions, is Chrome updates. Yes, Chrome updates arrive automatically. We can't choose when to receive those. I mean, they arrive to the GitHub Actions runner images, and at one point we just have those. We don't necessarily have the new version for all of the builds because there's a step-by-step rollout that GitHub does. And what we see is that these can break our tests a lot of times. They can break them in very funny ways, like certain browser commands just stop being reliable. They can break visual verification tests because the font rendering changes, and all of these kind of things. I see that TestContainers doesn't have anything related to browsers or Chrome. What would be your suggestions to work around this issue of Chrome updates randomly arriving and breaking our tests?
So yeah, the UI testing is one of those things where it's really hard to containerize or isolate from all of the other behaviors. We actually have, and I'm going to show later, some headless browser automation inside of the password server code or tests that we use to make sure that the passkeys work and things like that. But that's not necessarily UI test. It's more like browser interactions. I think that those issues, at least specific to like the UI aspects of the browser interactions and UI tests are going to largely be the same. And TestContainers is more about making sure that the setup for your dependencies, such as, like you said, MS SQL, although it's not an issue, it makes it a lot simpler to go from one environment to another. So you'll have exactly zero overhead, like for example, taking it from your local environment to your testing environment. You don't have to add any new steps to GitHub Actions. It'll all be taken care of by your test setup. But if I understand correctly, your main issues is that like they're just basically things that make it difficult to have a consistent testing process when it comes to UI tests. Is that correct?
It's not necessarily consistency. I mean, our tests are reliable under the same software environment. But the issue is that Chrome is basically an external dependency that we don't control. Unlike NuGet packages where we can choose when to update, and then we can check out our test suites for incompatibilities. But these just randomly arrive Sunday morning, and then suddenly half of our tests are broken because something random changed in Chrome or Chrome driver. We are not sure, but mostly it's Chrome. That's our suspicion.
Yeah, I understand that. And I think there's no good answer to this. The way we handle it is usually that we fix the specific version of the Chrome driver, and we kind of just say that it's tested on this version, and we update it every once in a while. But obviously, if you have to make sure that it also always works on all of the latest versions, it's a dependency on external things you cannot control, and you have to make sure it works. So there's not really a good solution for that. At least TestContainers probably does not help you in this case, I think.
The unfortunate thing is that we can't even pin it. We use GitHub Actions for every CI. Locally, it would also be an issue, but the bigger pain point is CI, and in GitHub Actions, these just arrive with the runner image updates. We do pin the runner OS version, but just one part of it. These continuous updates just come every other week, and we can't do anything to select these or delay or nothing really.
Well, I think it's definitely a trade-off for an issue that is interesting. But yeah, I don't think test containers is necessarily a solution that helps with that. It's more like orthogonal to all that altogether.
Do you pin the Chrome version at Bitwarden?
Sorry, what?
You pin the Chrome version, as you mentioned, at Bitwarden?
Yes, yes.
And how do you do that? Do you use custom images?
No, we actually we use the Chrome driver locally, so it's outside of the container, and we don't really care about we don't like have a visual interface for an application or anything like that. So in Bitwarden, the things that we want to verify in terms of at least the passwordless app is the fact that the user can, for example, create a new passkey. They can use that passkey to sign in and things like that. And in order to go through that process, you have to interact with the browser, because the browser and essentially the platform on which it runs is responsible for taking care of passkeys. So specifically like the passkey workflow. And for that, we only need to automate the user interactions with the browser UI. Essentially, we don't really care how it looks. It doesn't really break all that often, although it has happened before. But ultimately, it's we just update it on our own every now and then by changing the version of it installed on the agents. Although I cannot really tell you how it's done because it's not really something I do.
Okay.
Yeah, but I can also share you, and I will share later some repository links that I'm going to be talking about, and maybe you'll find some of your answers there, or at least maybe I'll give you some ideas. So yeah, moving on, just before I'm going to be showing more code, the foundation atomic jar that is responsible for test containers has been acquired by Docker proper, the company behind Docker. It has actually happened a year ago, or a little more than a year ago. And what that means, at least to me, is that this is a technology that is pretty widely recognized as essential to the software development world. It's important. It's probably going to receive more support, at least like financial support from such a company. And if I were debating whether it's something that I want to invest my time in, knowing that at least it's endorsed by Docker Incorporated gives me a little bit more confidence. And so let's actually look at some code, because I've done a lot of talking, a lot of theory. And first, let's just take a look at a very simple example. Here we have, and this is taken specifically from the test containers documentation, so it's not something super interesting, but it's a good starting point. Here we have an XUnit test class with a single test case, and we can see there's some kind of customer service that is reliant on a database, and the database is Postgres. And in order to be able to run those tests very easily against a real database, instead of like, for example, interchanging it with something else like SQLite, or maybe just replacing it with a mock like altogether, we can simply run the database in a container, and all we have to do is go through basically three steps. So first, we have to configure the container, which is done through the Postgres SQL Builder, which comes from an extension package. Like I mentioned before, there are different kits for different database. There's obviously one for PostgreSQL, and it already comes with certain defaults for for that specific use case. Here, they're providing a custom image name, which is not necessary, but they probably want to show that you can still override those defaults, and if you need a specific version of Postgres, so it doesn't change. So it's the same as what you have in your production environment. You can do that as well. And once that configuration is done, you just have to hook into the lifetime of your tests. In XUnit, it's done by implementing the async lifetime interface. And then when the test is about to initialize, you want to start the container, and when it's disposing, you want to dispose the container, which takes care of all the resources, make sure it's shut down, regardless of whether the test completes successfully or if they end in the failure. And then once you have that setup completed, in code, you can just reference the container that you have built using SQL Builder and get its connection string, which will have already an automatically generated connection string that you can put in your whatever this DB connection provider is. And as you can see, we didn't have to expose any ports or anything like that. We actually have no idea which port it's running on, or like which port it's exposed to on the host machine, but it's already taken care of by PostgreSQL Builder, and the generated connection string has all the necessary information. So all of this, nothing here is particularly difficult or complex or honestly interesting, but you can see how much work the test containers, especially like all of those packages that take care of specific services, can do for us, so that we don't have to think about it. And now let's take a look at an actual demo. So just to make sure, do you see the code properly? It's not too small or anything like that. I assume you do. So yeah, anyway, this is, I have two projects up.
Sorry, a second.
Oh, was that delayed or lagging?
Perhaps yes, but I didn't quite get your question. Did you want whether we see it? Because we do.
Yeah, I was making sure the text is big enough.
Yeah.
Okay. So I have two projects loaded up, and these are projects that we are working on in Bitwarden, specifically the passwordless project, I would say. And just to briefly explain what it is, it's a service that allows application developers or web application developers to easily integrate passwordless authentication in their services. So you can use device passkeys without using any passwords, anything else, to create an account, sign into it, share that account with multiple devices, and things like that. And we have the passwordless server, which is the backbone of all of that stuff, including the admin console API. That's not super important. And then we also have a numerous amount of different SDKs for different platforms. And I just have one open specifically for the .NET SDK. And in .NET SDK, we have an SDK that works with our passwordless API, and we want to make sure that it actually works properly. So we don't want to replace that API with something else, even like it's in a different repository. We don't really necessarily have access to it. It could be other people working on it, but we still want to use the real thing without going through the hassle of creating like a new application on the actual production environment and things like that. So obviously we can containerize it, and this is basically how it's done. So you can see in this setup we have several testing projects. They're not super big because the SDK is not really all that big. And there's a share project which is called Infra. And here we have that test API class, which is kind of similar to the async lifetime that we saw in the sample earlier, but a little bit more complicated. And this takes care of setting up three, I guess, objects, but two containers ultimately. So it takes care of setting up the network on which the database and the API is going to communicate, and then the actual database and the API. So when the tests are running, we're going to be having the passwordless API working with a real MS SQL database, which is also running in a container. And then we will have our SDK just tested as we normally would by communicating against that API using the URL that it exposes through the container to the host machine. The way the setup works is a little more complicated than in the sample before. But you can see it's kind of similar to, for example, Docker Compose or similar orchestrators, where you just outline the services that you want to be using. You specify which images they're using, their network communications, environment variables, and things like that. So going from the top to the bottom, we have the network, which is just used so we can have the container or the API container communicate to the database on its own network, so we don't have to expose both of them to the host machine. We have the database container, which is using MS SQL. Very similar to the Postgre builder, it comes with a lot of defaults that we can use, and we also do provide a custom or image name just to make sure that it's always consistent and it's always the same version. Because we don't really, like you said, like we don't want to accidentally have suddenly have tests breaking because there's a new version or something. We want to have some control over it. So this gets changed manually when, for example, our production environment database changes. And then we set up the network connected to the network we just built earlier. Set up an alias so that we can use the connection string properly to communicate to this database. And then we also set up output consumers for logging purposes. I'm going to go back to this a little bit later, but basically what it does is that it takes all the standard output and error from the container and it writes them to these streams that we created here. And then finally, we have the actual API, which uses this image. So there is, so we have the passwordless API, but we also have a kind of like a test version of it, which is stripped down of a little bit of the things like, you know, like payment and some other infrastructural aspects that are not essential to how the product is actually working, but more essential to how it's like being used with paying customers and things like that. And it's deployed separately on Docker Hub as test Bitwarden and passwordless test API. And yeah, we specify the image, the tag. We make sure that it's pulled always. There, I believe, 3 different options, and by default it's missing. And we want to make sure we always get the latest instance of the stable version. So if that label is overwritten, which happens whenever we release a stable new stable version of the API, we want to make sure we pull it so that we get the latest stable version in our tests as well. We can also just choose to use a specific version if you want, but you know, we want to make sure that it's tested against the latest stable version. And then we have a lot of environment configurations. Some of it is just generic. For example, we have to, for this specific reason, we have to set the environment to development to run migrations. So that we don't have to like manually execute any scripts, which we do on the production environment. You may have a different setup where you don't need this. This is the only reason why this is required. Then we set the ports properly so that the application knows which port it's supposed to be talking to inside of the container so that we expose the right port. This is set by the standard environment variable, and we also have a constant that dictates it so that, for example, when moving from, I believe, .NET 7 to .NET 8, there was a change in how what the default port was from just 80 to 8080. So if we didn't have that, that would break our testing API in this case. So we wanted to avoid it by hard coding it essentially, or using environment variables for it. And then for the main purposes, we have the management key, which allows us to make some managerial actions on the API. And then we, of course, have the connection string. So here we don't use the auto-generated connection string because I actually don't remember why, but we don't for some reason. Yeah. In any case, we have a connection string. And we basically use the MS SQL Builder's property to just refer to the port that it's exposed on, which is a constant, and then username and password. So we don't really have to make a lot of assumptions about how the container is running. We just use the properties that it uses itself. Again, connecting the API to the network, exposing the port. And the way it works is, again, that you specify the port on which the application is running internally, so the port that it's talking to inside of the containers, and then we just pass through to assign random host port. So it just chooses a random host port. We don't really care what it ends up being, and we don't specify it ourselves, so that when we have multiple instances of these tasks running at the same time, for example, on CI, we're testing against multiple target frameworks because it's an SDK that has to support .NET Framework, .NET 6, .NET 8, different long-term support branches and things like that. And we want to make sure that we can run multiple instances in parallel, and we don't want to rely on a specific port. So this just makes sure it's assigned at random. And then when we ultimately need to get the application URL, we can just get the map public port using the API that the container interface provides. And then finally, we have a wait strategy. So for custom containers, you kind of want to have something that tells you that the container is running correctly, that it's ready for use. And in our case, it's more than just it being running and finishing the initialization sequence. We also want to make sure it can accept HTTP requests, and it's successfully connected to the database, and it has run the migrations and things like that, which is taken care of by these kind of like basically health checks that are exposed on our API. And when those health checks all start returning HTTP status of 200, we can assume that the API is launched, has performed migrations, and is ready to accept requests. And so up until that happens, the container will not be considered to be fully initialized. And then we also have output consuming. So the way I think it's best to explain it is just to run a test. So let's take a random test. We have, I can create a register token, which is using our SDK to call a method and make sure that the token starts with the correct string. We don't really know what the token is going to be like or what features it's going to have. We're going to test later that we can use that token to sign up. But for this specific behavior or interaction, we want to make sure that we get the right token. And the way it works is that we call the create client async methods. And it happens after the containers have started, and it uses our own API to create an application, because in our domain there's different applications, and for each application you have different users, and so each test is basically a different application, which kind of takes care of isolation for us, so they're not going to have any conflicts with each other. And we do that by using simply an HTTP client to send a request and get the API secret and API key for our application. The same way you would do that in production. When you create an application, you will see a screen that tells you, here's your API secret, API key. This is just doing that, programmatically. And once that's done, we're just initializing the SDK, so the passwordless application, and then creating a client right here with those options. And once we have the client, at this point, we can call any method on that client that the user would normally call. So just this line alone takes care of starting the API, the whole server that manages the passkeys, manages all the different applications. It takes care of starting the database that the API needs in order to persist its data, and it makes sure that they can communicate together with each other. And on top of that, it also creates an actual, instance of the SDK, the iPasswordless client, that we can use straight away. So it simplifies the setup phase down to one line. Of course, it's not like you don't have to. It's important to like understand what happens, but you don't have to know about it. All you have to know is you get an SDK that's set up the same way user would set up theirs, connected to a specific application on specific instance of the API. And then again, once we have that, we can just call normal methods. They send regular HTTP requests, and they get handled by the real API, but just running in a container. So here, I put a breakpoint here. So let's just see exactly what I talked about more in detail, so you understand the order of things. And I'll just run this in debug in .NET 8, and also have Docker Hub or Docker Desktop open here, so we can see what happens to the different images in the container. So right now we don't have any containers running, and we get to the initialize the async method because it's used by the tests through the test API fixture. And then this is called, and we have a few methods that set up different containers in the network. So we set up the network. We have the that instance there. We set up the database, which has to pull the image and run it. So we can go and see what is actually happening here. We can actually see the container probably and see what's going on. So that was all of that time it took was to run the MS SQL database. And then finally, we just run the API container. And again, here it is. We can see the logs if you want. And for some reason, it takes longer than, oh, maybe it's still pulling. Yeah, it just took a while for some reason. Normally, it doesn't take that long, but in any case, that's how the containers are being launched. And you can see that we actually have 3 containers running, not just the SQL database and the API server, but we also have this test containers group, which is just a container that manages the basically other containers, make sure that the resources are disposed properly, even if the tests just outright crash and fail. It basically just does some managerial things, infrastructural things in the background. Here we saw that we also have a timeout for this process. And the reason we have it is because we may have an issue where, for example, our API will never fully be initialized. And that's because this testing strategy makes sure that these health checks respond with successful status codes, but it might happen that they never do because the test or the API server just never fully launches, or like there's some issue connected to the database. And in order to make sure that it doesn't just hang the test, we have a timeout. And then when the tests end up failing because of the timeout, we can look into the logs to see what exactly happened for it to fail. So now I actually pressed F10, so I'm not sure. Yeah, there you go. So now that we called create an app, I think I actually skipped this one, so my bad. But in any case, we at this point, oh no, never mind. We just got here. My bad again. So yeah, we're creating the app, and like I said, we're sending a request. Nothing special here. We get some response from a real server. As you can see, it's running locally or exposed locally on this 603.68 port, and it returned a response message which contains the API key and secret that we want to use inside of the app. There's actually 2 for, again, the main specific reasons, but we only need one of them, one pair of each. And so then we can extract it and then create the application, which exposes a method to create the client. And then we have a working SDK client. So we can just use the methods as we normally would. We call this method, which sends some request to the server, and we get the response. So again, pretty simple. And then finally, once the test is completed, it will eventually reach the dispose async method through the fixture, and that's where all of the containers are actually disposed and made sure that they're not lingering after the tests have completed. This container will still stay a while for a little bit, but it will clean itself up on its own. And so this is basically what the test cycle looks in a single on a single test example. You can see also we have logs written out here. So the way it works, again, earlier we set up with output consumer on all of our or 2 of our containers, and then we have a method called get logs, which just kind of converts them to strings. And then you can also read them iteratively if you need to, but ultimately the reason we need logs is because, for example, if there's some communication issue between the API and the database, or there's an error where the API just normally doesn't return a very descriptive error, but it still logs it to the output, we want to be able to see it. And so when we, in our API test fixture, or test API fixture, sorry, actually in the API test base, which is where our tests, from which our tests are inheriting, we have a dispose method that makes sure to write all of the logs from our API in the database. You can have it set up in different ways. This is just the way it's set up here using XUnit fixtures and some inheritance. It's not necessarily the best way, or it might not work for every testing setup. And actually, we'll see a different testing setup in a different project, but this works here and it's pretty good. So yeah, we get the output. We can see what the API was doing. We can see if it had any errors as well, and then also the same for the database. So for example, if this fails on CI, these logs will be super helpful in understanding getting more context to the reason why the test has failed. So you might get like, for example, here, one of the assertions can fail. For example, it doesn't start with the register, but in order to understand why, you will probably look into logs to see why the server returned with that specific response. And this is also where logging in general is helpful as well. And so if we run all the tests, at least from this project, without debugging, we can see again the whole life cycle going through. You can also notice that the biggest overhead is actually the database and then the server. So pulling the database takes quite a while because it's massive, 1.65 gigabytes. So this is one of the main considerations, like how much time are you willing to, or like one of the main performance considerations is the time it takes to pull the image, and not so much the time it takes to run your test against a real container. And once that's done, the tests have all completed. You may have noticed that it took a little bit of time to get them running. So there was a little bit of delay between it starting and any of the tests completing. And then once the first test completed, they all kind of completed one after another. And that's because we reuse the same container for all of the tests. We just have different applications within our API to isolate each task from each other, so there's no overlap and things like that. There's also different strategies to that, which I'll cover in a bit. But that also means that once the test setup has completed, all of the tests after that will pretty much complete immediately. So if you have one test and the testing, the time it takes to set up all of the containers is, for example, 20 seconds, then that one test takes 20 seconds. But if you have 1,000 tests, it's probably going to still take around 20 seconds, 25 seconds, 30 seconds. So it's not going to be a lot longer, but it's going to be a lot more tests. So there's some overhead you have to pay initially, but then you get the better results depending on how many tests you have. So it scales well with the number of tests.
Related to that, I also wanted to ask, is it an issue if you run tests in parallel on the same container, or would you start multiple container instances, even though those would still just pull the image once, but still run in parallel?
That's a great question. And I was actually the tests running here were not running in parallel. I can run again, and you see that they are running sequentially. On CI, they typically do run in parallel. I think I'm actually not sure if you can configure in Writer to run them in parallel, but there's no issue because this part of the initialization, the test API, is shared across all of the tests that need to share it. And once the container is running, once the database is running and the API is running, each test then uses different applications for each of them. So it doesn't matter how many of them you run in parallel. It doesn't matter like if you have multiple containers either, it'll all work just fine.
Okay, so it does start multiple container instances now.
In this case, it starts only one because we're running against one target framework. But if I, for example, so again, this would only, I think, work sequentially in Writer, but imagine you're on CI and you're running against .NET 6 and .NET 8. Actually, I don't know if I might not have .NET 6 here, but imagine we're running against two of these frameworks. Then there will be two test executables or test agents running at the same time, and each of them will have one set of containers. So there will be two containers running for each of them. And the reason that's not going to cause any issues is because they are all running on yeah, I don't have the .NET 6 installed, unfortunately, but they have different ports that are exposed to, and each instance of the test talks to their specific instance of the container.
Okay, thanks.
Mm-hmm. But yeah, like again, with parallelization, that scales really well. So one of the reasons we want to use test containers is isolation. That's kind of why we want to have containers in the first place. We want to be able to have our dependencies that are as close as possible to what we have in production, but still something that we can isolate, work with in parallel, and not have to worry about too much. So this was kind of the overview of the tests. I see I'm kind of running out of time. Do you have like 10 more minutes, or should I try to make sure I end it faster?
No, we're good.
Okay.
We're good to continue.
Yeah. All right, that's great. So I'm gonna switch to the server tests to give a little bit more perspective of how it works in a big picture environment. And before we actually dive into tests, we're going to look in the Docker file for the image I was talking about. So this image that we pull for the container right here, we build it ourselves, obviously. And one thing, like, there's nothing particularly special about this. This is a pretty basic ASP.NET Core Docker setup. But one thing you should probably keep in mind is that you want to be able to target multiple platforms. And as you can see, where we pull images, we actually have the switches which dictate which type of platform we want to build for, or which platform the image we want to pull, and then later which platform we want to build for. And that makes sure that we at least cover the two main architectures, which is ARM64 and AMD64. And that's because, like, when you're running on CI, it's for the most part, it's probably going to be AMD64, so like something like Linux running on x64. But luckily, we have developers running with different setups. We have people on Windows with Intel chips or something else that are in the x64 architecture, and we have people on M1, M2, M3 Max running them on ARM64 chips. And Docker is pretty much platform agnostic as far as the host is concerned, and that's partially achieved by having an emulator that can transform or translate instructions from one architecture to another. But .NET specifically doesn't work really well with emulation, and in many cases, your application will just refuse to run. And the way we make sure that doesn't happen is that we build our application for a specific runtime. We build it as a self-contained application, so we don't rely on the runtime being installed locally. And then, like I said, using these switches, we make sure there are two versions of it. And let me show you the actual CI workflow, or specifically the Docker workflow. And here we have a job that uses Docker buildx, and it passes the platform option and specifies Linux, AMD64, and ARM64. What that results in is that we have two images, or a bundle of images, that we later push to the registry. And then if you're, for example, on a Mac that uses an ARM64 chip, you'll get the right image for your system, so you will have the API that can run on your system. And likewise, if you're on Windows or Linux or older Macs, you'll get the AMD64 version that's also going to work on your system. We also have some other switches here, which are not super important to what I'm talking about, but basically this is how we build and push our image. This entire job kind of takes care of that, but this is the main part, which uses the Docker buildx toolkit in order to create the image and push it. And then in the server itself, we also have tests. We actually have a mixture of different tests, so it's not just tests using test containers, but we do have tests using test containers. And here we don't really have that complicated of a setup, because we only really need to use to expose the database from the container, but we are using the web application factory / test API from ASP.NET Core in order to automate the setup related to the actual application. So here we have the API. We also have the fixture, which sets up the MS SQL container the same way we had it in the other project. And it just basically creates the API, passes the connection string the same way. Here we don't really have any network to talk on. This is exposed to localhost. So we just connected using the built-in connection string. And you can see the test cases kind of taking a little bit longer to run because they're more involved. They actually use, at least a lot of them use the browser automation, like I mentioned. And if you look at the containers, it's pretty much similar. We have a database. We don't have the API because we're testing the actual API, so it's running in process. And then the tests are completed, the container is extinguished, and everything is good to go. Again, with parallelization, you can have multiple of these test cases running in parallel. They can talk to the same database, which is not an issue. And again, I'm going to talk about some isolation strategies later. But this is basically how it works. And also just to briefly show you a test. Yeah, so this is a test that uses the browser automation. So it creates a WebDriver and it which is kind of like set up here. So make sure that it has all of the authentication settings enabled for what we need. There's a lot of this browser automation voodoo that probably everybody is familiar with, and some other stuff. And ultimately, what it does allow us to test not only how our API behaves to user requests, but also how the data that the user receives from our API can be used with the browser. So in our case, it's to create an authentication session and sign in. Again, I will post links to this repository so you can look at them in more detail. And if you want, I can also answer any questions. I don't want to focus too much on them, but yeah, basically we have an API that is being tested by running a SQL database, and inside of the test, we also have the actual API running in process using the test automation API by ASP.NET Core. And finally, we also have Chrome browser automation tooling to make sure that it can interact with the browser properly in certain cases where we need to perform authentication. And then the SDK is tested one level above, where we also have the API, and we talk to the API directly. There are no mocks or stubs in any of those projects. Well, actually, we just have some tests that use them, but for other reasons. But ultimately, yeah, we have a lot of coverage that is done purely through integration tests. And again, you just need to clone the project. You have to have Docker installed, and that's it, nothing else. And this will just work. You don't have to think about emulators. You don't have to think about installing or creating resources from different cloud services. Just run the tests and it will work the same way on CI, CD, locally, it doesn't matter. So going back to the presentation, I wanted to just touch briefly on a few topics that are important to what I was talking about. And one of them is performance considerations. So as you can see, tests, like when we were dealing with integration tests one way or another, there's going to be some slowness involved because there's a lot of infrastructural concerns that are being used or they're being tested. And so when we're designing our test suite, we have to consider what exactly makes up the biggest part of that. And like I already said, Docker pull is the slowest part. So pulling a new image takes the longest amount of time. So if you already have if you're just starting out and you're cloning a repository, you'll not probably have the image in your local Docker cache, and so the test will take longer. But once you have it, it will just make sure that the image is the same version or the same tag as the one that you specified, and it will not take nearly as long. And then also when you are in control of the images that you are using, for example, here we're in control of the API and the Docker image of it, we want to make sure that it's as small as possible. And so here, just going briefly back to the Docker container, that we're doing that by making sure we're building a self-contained image. And we're only using the runtime dependencies, so the most minimal Docker image size we can go for in our API container, so that the pull time is the shortest, because it depends on the size of the image. And it only just mainly affects CI environments because, that they have to pull the images every time. But a lot of the popular CI environments, such as GitHub Actions, have many popular images in their cache already. So SQL Server is going to be there, so it's not going to need to be pulled and things like that. But obviously, they'll still have to pull your own images for your own services and things like that. Cold start is definitely an overhead, and as you could have seen, there's 10-20 seconds or something of that in here, but it's constant. It's not something you have to deal with each test. It's something you have to deal with once. So again, like one test and 1,000 tests is pretty much the same in terms of test duration, because you only have to pay the overhead in the beginning. And so if the more tests you have, the more efficient your testing suite becomes as a result. And you don't really have to deal with considering whether it's worth the effort or not, as you would in normal setups where you have to create or start a dependency for every test, but you only have to do it in the beginning. However, that depends on the isolation strategies you use, and some can yield better results than others. And the isolation strategies are as follows. So you can have, for example, no isolation at all, which means that you have, in this case, just one container, for example, with one database engine with one database, and every task just talks to that database, writes data there, and there's no kind of isolation done there. And that can be fine for example, for read-only operations or write-only operations that don't change data that already exists. So if they're only adding new data and not like overwriting anything, so that your tests don't have to run sequentially or make sure that they're trying to not touch on each other's resources. But if that's not the case, there are other strategies that you can go for. For example, here we use domain isolation. And because in passerless domain, we have applications, which are a way to isolate different, essentially, applications for our users, and then each of those applications can have its own scope where you can create new users, you can register, you can sign in, and it cannot affect any of the other scopes or any of the other applications. And this setup uses the same database environment, the same container. It's shared across all the tests, but because it's isolated at the main level based on the tenant, they don't overlap again, and there's no conflict. Sometimes that's still not possible, and you may go for a different isolation strategy, which is storage isolation, where each task still share the same environment, so you still have the same instance of the container, in this case, for example, a database, but a database engine specifically, but each task still gets its own database instance. So you can have a Mesh SQL server running in a container that is like a single container that is shared across all tests, but each task creates its own database, which is much faster than starting the actual server, the actual engine. It doesn't take nearly as long, and because each task gets its own database, they again cannot overlap with each other. And then finally, when for some reason that doesn't work either, you go for environment isolation, which is where each task gets its own environment completely. So for each test, you got a completely new set of containers running, and each test pays the overhead of the startup each time it runs. And this is the least or rather ideal setup because of, again, the cold start overhead being paid for each test instead of once at the beginning. And this is probably the setup you want to avoid. If you have to do this, make sure the containers you're running are fast to start. For example, MS SQL Server specifically is very large, is a really large image, and it takes a while to start up. In other projects, we use Redis, which takes a lot faster. Again, like if you're only depending on services within your own environment, then you can control how small the image is and how easy it is to pull. You may pre-cache it and things like that. But ultimately, it's not ideal. You want to go for probably at least storage isolation or domain isolation. And if you can, probably no isolation, but that almost never happens in practice. And in summary, I just finishing up on this talk/workshop/demo, I just want to say that we can summarize that testing against real dependencies is not really that difficult. Again, I guess as long as there's a Docker image and you can containerize everything, if you're dealing with UI tests that have to run on an actual agent, it might get a little bit more difficult. But for a lot of use cases, it's not as difficult as a lot of people are assuming. And it can be quite fast. If you set everything properly, it can still take a lot less time to diagnose issues and figure out what's not working in your code than you would if you had much faster tasks, but that wouldn't provide as much confidence. And it does simplify testing code as you saw, because we don't have nearly as much setup involved in each test. We only have a single reusable infrastructure that we take care of universally across all of the tests. And then each test just takes care of the work that is specific to the behavior it's trying to verify. And such tests, as a result, provide more confidence, because I know that, for example, my SDK is talking to the real API. It's not mocking the responses coming from it. It's using an actual HTTP client that's sending actual requests and getting actual responses. And TestContainers specifically, it's a framework, or in a way it's an ecosystem or like a tool chain that supports many different development platforms. You can use it in .NET, Java, Node.js, Go, and all other kinds of ecosystems. And it's a way to run Docker containers specifically for testing purposes much more easily. So you don't have to take care of cleanup, you don't have to take care of port routing, you don't have to take care of like how to set up wait conditions for MS SQL databases or Postgres databases. This is something that it already does for you. And testable software, when we think about, oh, we want to be building testable software or design testable software, it's not something that just means dependency inversion and interfaces, which it also includes, but it also can mean something about building architecture that supports testing against real dependencies more easily. So, being able to containerize your applications using dependencies that are easily available as containers. So, probably open source dependencies and like MS SQL database. I'm not sure if it's open source, but in any case, or Postgres or Redis and things like that. Making those decisions can make it much more easy to build software that is actually testable, but just in a different way. And thank you for listening. I hope you found at least something here useful. And if you have any questions, I'll be very happy to answer them.
Yes, thank you very much. I don't have any further questions. Anybody else by chance?
Me neither, but thank you.
Yeah, and if you don't have questions right now, I'm still available, using email and things like that, or whichever form of communication we may find. And I'm still happy to answer other questions. I know that, I was kind of quick about going through all of the details. So if you want to know more about specifics, let me know.
Okay, great. Thank you very much. I think this was it.
Okay. Thank you for inviting me.
Thank you. Bye, everyone.
Thank you.
Thanks.
Bye-bye.
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 Goodbye.